Imagine a time capsule frozen for millennia, now slowly opening. What if that time capsule holds not just relics, but secrets about our planet's ancient past, about life that thrived eons ago? The Arctic's melting permafrost is doing exactly that, revealing discoveries that could rewrite history as we know it. Prepare to be amazed. Scientists are unearthing perfectly preserved creatures, viruses, and even entire ecosystems, some dating back hundreds of thousands of years. These aren't just curiosities, they're windows into a lost world. The clock is ticking in the Arctic. Join us as we head to the front lines of this dramatic thaw and uncover why these revelations from the ancient Earth matter more now than ever. Section 1. The Big Thaw. Let's start with what's happening right now. The Arctic is warming nearly 4 times faster than the rest of the planet. In 2024, permafrost temperatures hit record highs, some regions warming a full degree Celsius per decade, a rate unseen in 2.6 million years. Permafrost, ground frozen year-round, covers 23 million square miles across the Northern Hemisphere. For millennia, it's been stable, solid, untouchable. That stability? It's crumbling. At Alaska's Prudhoe Bay, salt water now regularly washes over tundra that has been frozen solid for thousands of years. By 2050, nearly 70% of Arctic infrastructure will sit on high-risk thaw zones. And this isn't slow erosion. These are retrogressive thaw slumps, entire hillsides collapsing, revealing layers hidden since the Ice Age. In Siberia, the Batagaika crater, nicknamed the Gateway to the Underworld, grows larger every year, a kilometre-long scar carved by melting permafrost. Section 2. Unearthing the Past. Now here's where things get extraordinary. What emerges from this thaw looks like science fiction. In December 2024, scientists unveiled Yana, a baby woolly mammoth discovered in the Batagaika crater. After 50,000 years, her trunk, ears, mouth, even her fur remains intact. But the real revolution is deeper. Researchers extracted RNA from a 39,000-year-old mammoth named Yucca. RNA usually vanishes within hours after death, yet here it survived nearly 40 millennia. Dr. Love Delaine explains, these RNA molecules reveal which genes were active at the moment of death. Yucca's cells showed signs of extreme stress, possibly from being chased by predators. And it's not just mammoths. A 57,000-year-old wolf pup named Jour, 32,000-year-old saber-tooths, ancient plants with intact DNA. The permafrost holds an entire Ice Age ecosystem, preserved at the molecular level. Even more shocking, a 52,000-year-old mammoth sample revealed 3-dimensional chromosomes. The DNA had entered a glassy state, like freeze-dried genetic architecture frozen perfectly in time. Section 3. Dangers from the deep. But these discoveries have a sinister side. Permafrost isn't just a freezer, it's a carbon time bomb. The Arctic stores 1,700 petagrams of organic carbon, twice what's in Earth's atmosphere. When thawed, microbes wake up and start decomposing it, releasing CO2 and methane. In Canada's Mackenzie Delta, methane emissions from thermokarst lagoons are 18 times higher than surrounding land. It creates a brutal feedback loop. Thaw, gas, warming, more thaw. And then there are the viruses. In 2023, scientists revived 13 ancient viruses from Siberia's permafrost. the oldest 48,500 years old. Zombie viruses, they call them. We've already seen what can happen. In 2016, an unusually warm summer in Russia's Yamal Peninsula thawed a decades-old reindeer burial ground. Dormant anthrax spores were released, infecting over 2,000 reindeer and spreading to nearby communities. A 12-year-old boy died. The outbreak was contained, but it served as a stark warning. Climate scientist Emily Jenkins has found something equally troubling. As polar bears spend more time on land due to sea ice loss, they're increasingly exposed to mosquito-borne viruses that are now present across the Arctic from Alaska to Greenland. The pregnant females, spending 8 months on land, show significantly higher exposure than males. And there's another immediate crisis: infrastructure collapse. In Alaska alone, damage to buildings and roads from permafrost thaw could cost between $37 and $51 billion by mid-century. Houses are tilting, roads are buckling, pipelines are at risk. The 2020 oil tank collapse in Norilsk, Russia, spilling thousands of tons of diesel, was partly attributed to permafrost instability. Section 4. Unlocking our future. Yet within these challenges lies unprecedented scientific opportunity. These ancient specimens are teaching us lessons crucial for our survival. The DNA recovered from Ice Age plants and animals is revealing how past ecosystems responded to rapid climate change. When the mammoth steppe transformed into modern tundra between 15,000 and 10,000 years ago, temperatures shifted by up to 10 degrees Celsius within centuries. By studying which species survived and which perished, scientists are identifying traits that confer climate resilience. Archaeological discoveries are rewriting human history. Newly exposed sites in the Arctic are revealing migration patterns, showing how our ancestors adapted to extreme environments. These finds help us understand the relationship between climate, resources, and human survival. Lessons directly applicable to modern climate adaptation strategies. The medical applications are equally profound. Dr. Mark Friedlander at Stockholm University points out that if we can extract RNA from 40,000-year-old tissue, we can potentially study the evolution of RNA viruses like influenza, HIV, and coronaviruses by examining ancient samples. This could revolutionize our understanding of pandemic diseases and how to combat them. The preserved genetic material is even advancing de-extinction efforts. While bringing back the woolly mammoth remains controversial and technically challenging, the intact chromosomes and RNA provide blueprints that were previously thought lost forever. But these discoveries raise profound ethical questions. Who owns these ancient remains? How do we balance scientific inquiry with the cultural significance these sites hold for indigenous Arctic communities? As the land shifts beneath their feet, these communities are at the front line of both discovery and disruption. Section 5. The race against time. The Permafrost Carbon Network, coordinated by Dr. Ted Schur at Northern Arizona University, represents a 15-year effort aggregating data from across the Arctic. But they need more. What's desperately needed are comprehensive early warning systems. Currently, only 3,000 monitoring probes cover millions of square miles of permafrost. Dr. Anna Liljedahl from Woodwell Climate Research Centre emphasises that we lack broad-scale hazard identification and real-time tracking across the Arctic. Innovative solutions are emerging. engineers are developing passive cooling systems using thermosiphons, devices that keep permafrost frozen beneath critical infrastructure without requiring external power. Reflective materials are being tested to reduce heat absorption. Some communities are experimenting with snow manipulation techniques to insulate the ground in winter. But technology alone isn't enough. Permafrost thaw threatens up to 3 million Arctic residents, yet it's not officially recognized as a natural disaster by many governments, making it harder to obtain emergency funding. Climate policy researcher Lynn Heller argues that permafrost emissions must be included in national climate commitments under the Paris Agreement. The stakes extend far beyond the Arctic. Accelerated permafrost thaw could disrupt the Atlantic meridional overturning circulation, the ocean current system that keeps Europe mild. Its slowdown could trigger drastic weather shifts worldwide, creating a cascade of climate tipping points difficult to reverse. This isn't just about preserving ancient specimens or protecting distant infrastructure. Indigenous communities are watching their ancestral lands transform, their traditional knowledge challenged by unprecedented change. In Chevak, Alaska, residents have lost over 7 feet of ground in some places, with homes and culturally important buildings now at risk. The Arctic's thawing permafrost is opening a window into our planet's distant past, while simultaneously threatening our future. Each perfectly preserved mammoth, each ancient virus, each collapsing hillside tells us something crucial. The Earth's climate system has tipping points, and we're approaching them faster than we thought. These discoveries aren't just about what we've lost, they're about what we might still save. By understanding how life adapted to past climate upheavals, by developing technologies to mitigate permafrost thaw, by recognizing the urgency of this crisis, we gain tools for our own survival. The clock is ticking. The permafrost is melting. But within its thawing depths lie lessons written over millennia, lessons we must learn, and learn quickly, if we're to secure a livable future. The secrets of the ancient Arctic are being revealed. The question is, are we listening?